What's up, Algebros? It's Mr. C here, and in this video we are going to sketch the graph of this rational function via an analytic technique. Let's go ahead and get started. So the first thing that you want to do is factor both the top and bottom if possible. You'll notice that the top is simply x, so that's not going to factor any further. The bottom is a quadratic function that does factor, and it factors as quantity x plus 2 times quantity x minus 1. Now you'll notice that none of the factors from the top cancel out with the factors in the bottom, so what that would mean is that there is no hole that we'll have to plot for this rational function. So down here I've got a little laundry list of items that we can fill in as we do our analytic approach. So where it says hole, we'll just write out the word none. So since there's no hole, we'll move on to identifying the vertical asymptotes. And the trick to figuring out the equations for these guys is to set your denominator equal to 0 and solve for x. So I'll use the factored form version of the denominator. So x plus 2 times x minus 1 equals 0. We'll set x plus 2 equal to 0, and we'll also set x minus 1 equal to 0. And they're going to be two vertical asymptotes. One is going to cross the x-axis at -2, and the other will cross the x-axis at +1. So there's a line item for VAs, and I'll write out each of those equations. X equals -2 and x equals +1. So keep in mind that these are two values of x that create division by 0. So what that means is that, in terms of the domain, we'd have to exclude them. So the domain is going to be the set of all x such that x cannot equal -2 and x cannot equal +1. Now in terms of horizontal asymptotes, or a horizontal asymptote, you want to compare the degree of both the numerator and denominators. So I'll use the standard form version, or the original version of the rational function for this. The degree of the top polynomial is 1, and the degree of the bottom polynomial is 2. So this is a situation where the degree of the numerator is less than the degree of the denominator. That would be a case 1 situation where the horizontal asymptote is automatically the equation y equals 0, or in other words, the x-axis. Since we landed in a case 2 situation and not a case 3 situation, there's going to be no oblique asymptote. So where it says OA, you can just write out the word none. Now to figure out the x-intercepts of the rational function, what we're going to have to do is set the numerator equal to 0. And regardless of which version of the rational function you use, you're going to get x equals 0. So there's just one x-intercept, and that would be at 0, 0. Now for a y-intercept, what we have to do is plug 0 into the rational function. And what we would get, say if you use the standard form version, is 0 on top of 0 squared plus 0 minus 2, which simplifies to 0 over -2, which simplifies even further to 0. So the y-intercept would be at 0, 0. So there's just one x-intercept that's at 0, 0, and the y-intercept is also at 0, 0. So that's about all we can do by hand in terms of gathering information analytically. Now what we'll do is transfer this as best as we can into the coordinate plane. So there's one vertical asymptote, which we're going to sketch in as a vertical dashed line crossing the x-axis at -2. And there's a vertical asymptote crossing the x-axis at +1. The horizontal asymptote is something we can put in, and it's the x-axis in this case. So I'm going to draw a horizontal dashed line going along the x-axis and write out its equation, which is y = 0. And then we have both an x and y intercept at 0, 0. So what we'll want to do to infer the rest of the graph, which we can infer based on the number of vertical asymptotes. There are going to be 3 pieces. What you would want to do is go to your graphing calculator and in y1 enter in the following. We'll put parentheses around the numerator. We'll hit the divide key to get a fraction bar, and then we'll type in the denominator, the standard form version of it, in its own set of parentheses. So let me pull up my calculator. So in y equals, in y1, we'll have parentheses x, fraction bar, parentheses x squared, plus x minus 2. And if you have a TI-84, you can hit zoom 6. If you have a TI-83, I recommend pressing zoom 4. And those are the 3 different pieces to our rational functions graph. You can see that there's an indication of the horizontal asymptote along the x-axis, and there's an indication of 2 vertical asymptotes, namely at x equals -2 and x equals +1. So let me go back to my notes here. The branch furthest to the left will appear to be a little underneath the x-axis, and as you go from left to right, this vertical asymptote of x equals -2 will turn it down to -infinity. Be sure that you don't cross or touch any of these vertical asymptotes. The middle section of the graph starts out towards the top of the vertical asymptote x equals -2, and what it's going to do is snake its way through the origin, because that's where an x and y intercept are both at for this graph, and then it'll continue down to -infinity while getting closer to the vertical asymptote of x equals 1 on the left hand side of it. And you'll notice that this part of the graph actually does cross the horizontal asymptote, which is allowed to happen. But what you're not seeing this middle section of the graph doing is crossing either of the vertical asymptotes, because graphs can never cross or touch vertical asymptotes. And then the third and final piece goes a little something like this. And that would be our sketch of this rational function via the analytic process. As always, if you have any questions for me whatsoever regarding the content of this video, feel free to let me know. Otherwise, thanks for watching, and I'll catch you guys in the next one.